Hello guys, welcome back to AmanSoft TechInfo. This is Aman, and in this video I'm gonna introduce you what is OOP programming languages and what is basically Java and how you code simple application in Java. This is basically an introductory video about programming. So from today a series of my programming videos will be uploaded on my channel, which would include Java and C++ programming, from small programs to more complicated and more bigger programs like data structures and different type of GUI programs, graphical programs. So in this video basically I am talking about introducing to you what is OOP, which stands for object oriented programming language. So I will be introducing it, what is OOP, what are its basic features, characteristics, and I will be talking about Java, like what is Java and why should we use Java and how we code in Java, what all things you need to start coding in Java. So first of all, talking about OOP. OOP is an advanced version of programming languages that can associate things, programs, more or less similar to the real life objects. Okay, suppose we have a car. Okay, suppose we have a car. So what does a car have? It has wheels. Okay, what else? It has its body. Okay, talking about that, so now talking about body. Okay, so if we talk about body over here, so there would be some characteristics of the body, like its color or model or material, sorry, or material. So this is actually a real life object which has its car. So talking about its two features, its wheel and body. Body has some characteristics like color, model, material. And we're talking about the wheel. What would wheel have? Obviously it would have some characteristics like its color, its rim design, its diameter, circumference, and the tire being used over there. But here in wheel I would like to tell you there would be two more characteristics, like either the wheel is still or it's rotating. Okay, so there are two states of the wheel I am talking about. So if we talk about the wheel, we have got here two states. What it could be? It's moving or stop. Okay, or better you say rest. So this is what is a real life object. Real life object is the car. Its components are wheel and body. So the position of the wheel or the state of the wheel is either moving or at rest. Okay, and talking about the body, it has got some characteristics. It has got its color, its model, its material. So this is a real life object. So if we talk about object oriented programming languages, OOP, how can it relate the car with the program? Okay, so talking about object oriented programming languages, which is OOP, we write programs in a class. Okay, we write programs in a class which contains different methods, okay, which contains different methods, and different methods contains different functions. Okay, so what is a class? A class is equivalent to a car. It is the full body. What are methods? Methods are the components of the class, or you can say methods are the components of the car, which are the wheels and the body. Okay, these are the two components I have been talking about. Obviously there are going to be many components of car, like engine, its transmission, etc, etc. So these two are the this method are the components, and these functions are tell you what is the state of the method, or what is the state of the components. Like here the component wheel is either moving or is at rest. So they are the two cases. There are two states where the component can lie, either moving or rest of a car. So the same is done by function. It tells you what is the state of the method or the component, and each function contains some data. This data tells you what is the thing it's made up of, what task it gonna run, what return it gonna give. Okay, the same is just like the characteristics of the body. You can see its color. Okay, so it's tells about the color, the model, the material. It tells about what it is actually, what data it contains, what values it contains. So this is the way OOP relates with real life objects. Okay, so now talking about what are the basic characteristics, what are the features that make a programming language an object oriented programming language. Some of the basic characteristics of an object oriented programming language is these are very basic characteristics. First of all, it's data abstraction. Okay, I'm abbreviating it. It's data abstraction. Okay, so now talking about what is data abstraction. Data abstraction is a process of you can say combining every data, every function, each and every important part under an object. Okay, so in a way like in a way that you get only what you need. You need not know what is happening in the background. You put some data, you get an output, that's all. This is what is data abstraction. So taking an example of an electric switchboard, suppose you're using an electric board, it has got some switches. Okay, you plugged your you plugged your TV in over there, and you want to run your television. So what you'll do, you'll plug that plug in, and then you will put that switch on in the on position. So what you're actually doing, you're just putting the switch on. Okay, but you actually don't know what's happening behind that. What are the wiring connections done so that when you put that switch down, press that switch down, you get it on. So that is basically abstraction. You get what you do, what you need. You need not know what is happening in the background. So that is data abstraction. Okay, so data abstraction, suppose I have a class, or you can say I have some classes. Okay, each class have some functions, as I said, and each function has some data. Okay, so here comes abstraction. All the important data are stored in this function. Okay, and this function is stored, and a bunch of these functions are stored in an abstracted form to a method, and a bunch of these methods are in an abstracted form stored in some classes, and a bunch of these classes makes a package. Okay, so I'm not talking about the packages now. I am removing I thought of introducing it now, but I won't do that because basic. So I'm talking about the class. Okay, a bunch of methods introduced in a class. Okay, abstracted in a class. So this class, what the user gonna do, he is not going to see what all data is there, what all function it's doing, and what all methods or the functions contained in the class. What he is going to do is just run this class. When this class will be run, this method gonna activate some functions according to the need, and the functions according to its characteristic gonna take some data from the user, process that data, take the return data, and this function gonna return it to the method, and the method gonna display it in the result of the class. So this is data abstraction. Okay, so this was the basic data abstraction I told you about. And now, so what's the second component that makes it an object oriented programming language? The second one is so related to abstraction, like abstraction cannot take place without this characteristic, and this characteristic is encapsulation. Okay, I'm using abbreviations over here. Okay, so it's not practical to write everything over here. So it's encapsulation. So what is encapsulation? As I told you, we do data abstraction. We compile things together in a single object, like a bunch of this data. We took a bunch of this data, compiled it under a single name function. Okay, so the same defines encapsulation. Encapsulation is the process to compile all the necessary and correlated informations under a single roof or under a single variable or a name. Okay, so a bunch of these similar data or correlated data are taken together, compiled together, integrated together under a single name function, and a bunch of these functions are integrated or compiled under a single method, and a bunch of these methods, correlated methods, are compiled under a class. Okay, and a bunch of these classes are stored under a package. I'm not talking about packages right now, but I've just given a small hint. So it's the way to compile things, correlated things. Okay, correlated things together. Okay, so this was basically what is encapsulation. I don't know why I was writing the full sentence over here, so it's not needed. I think you would have understood what is encapsulation. So data abstraction, encapsulation, they both are related. They both cannot take place without each other. Okay, or you can say data abstraction cannot take place without encapsulation, while encapsulation is an independent thing. Okay, so what's another feature that makes it an object oriented programming language? Okay, data abstraction, encapsulation, and the third one is polymorphism. Okay, I'm using the abbreviation over here. It's polymorphism. So what is actually polymorphism? We know the meaning of the word polymorphism is combining or a series of same type of structures together. We have been learning polymorphism in chemistry. Like polymorphism is a process by which a number of same you can say functional groups or the carbon chains make bonds, form a bigger compound, smaller compounds form a bigger compound by combining themselves. That is polymorphism. So something the same, it's not exactly the same over here, it's a bit different over here. What we are talking about is polymorphism. Okay, so how do polymorphism work over here? So best example of polymorphism I would like to give in object oriented programming languages is function overloading. Okay, function overloading. Okay, this is the best example or the basic example you can give about polymorphism in object oriented programming languages. It's function overloading. Function overloading is a way you define functions with the same name, but where comes the difference is that while you're calling those functions, while you're calling you would know what are functions and how you call functions. In the coming videos I will be doing that, function overloading also. Function overloading, you call the functions are with same identity, but the difference is in their data. the data they store in, the data they return, there comes the difference, and we use that difference to call different functions with the same identity. So this is function overloading, and that represents polymorphism. Okay, there are much more characteristics of object oriented programming languages, but I'm not going to discuss all over here because the video gonna be too long then, because I need to introduce Java also over here. So this was something about a brief knowledge about object oriented programming languages, and I don't think so you would be interested in knowing all these theories. You would be more interested in knowing how to code in. So let's start with Java. Okay, so here comes Java. So talking about Java, Java was first named as Oak. Okay, it was first called OAK, Oak. Okay, and I'm not going to talk about the history of Java because that would make this video boring. Rather, I'm going to talk to you about why you should use Java and what's the features that make Java an advanced programming language. Okay, first of all, talking about Java. Java is platform independent. You can run Java programs created in Java on any environment like Windows, Mac. You can use even custom devices to use this thing. So Linux, etc., etc. There are many more operating systems. You can run Java minimum everywhere. Okay, so how is it possible? How can Java run all the programs on different environments? So first of all, what is an environment? We all talk about that this is different environment, this is different environment, and this is different environment. Listen, environment does not depend only on operating system. So if I talk to you, like presently I'm using a PC which is running on Windows 10 latest build, and it's running on i7 8th generation processor. Okay, Intel i7 core i7 8th gen processor. Okay, so my system is Windows 10 running on Intel Core i5 generation 8. Okay, so this is one environment. And if I take another PC, it is running on Windows 10 and it's Intel Core i5 7th gen. So what's the difference between those? Are they different environment? Or if I take another PC which contains Mac operating system and it's running on Intel Core i3 processor, or okay, let it be i5 processor or i3 processor, is it a different environment? So all these three conditions I talked, which is a different environment? Two Windows operating system, one Mac operating system, one i7, one i5, one i3. So which is different platform? I think most of you would say that the Mac one is different and both the Windows one are same. No, but that's very wrong idea that most of you have got that. Okay, I know most of you would have known the answer. The answer is actually all the three of the PCs run on different environment, because environment is basically a combination of the processor and operating system you are using. So in all the cases the processor was different, the operating system might be same in both, but the processor was different, so there was different environment. So here lies environment. So basically Java can run in all the environments. Okay, so how is it possible for Java to run in all the environments? So the answer lies in the way we run Java. We run Java on JVM. So what basically is JVM? JVM stands for Java Virtual Machine. So this is Java Virtual Machine. Java Virtual Machine is an emulation of an emulated Java environment. That is a software based environment, or you can say it's a virtual environment where your Java programs are created, run, and everything is done on JVM. Java Virtual Machine for different environments can run all the Java or jar files. It is so JVM might be different for different environments, but JVM makes the Java created applications platform independent. So you can basically download JVM. So how okay, where you get JVM? How can I get JVM? You need not download JVM externally from any site, because to start coding you would be downloading JDK. Okay, so what is JDK? It stands for Java Development sorry um, Kit. Okay, it's Java Development Kit. So Java Development Kits contain all the necessary data and library packages, library classes, and the compiler, interpreter, data that runs compiler and interpreter. It contains all the data and also the Java virtual machine and different types of library packages. I will be talking about packages as I said. So this is JDK and you need to download this JDK to start coding in Java, which will contain JVM. So we cannot directly code in JDK. Yes, we can do with command prompt, but since it is a video for beginners, I will be talking about how you can code using IDE. So another term, IDE, what is this? It's integrated development environment. Okay, it's integrated development environment. So what is IDE? IDE is nothing but basically an application that contains, so a basic IDE contains an editor, a compiler or interpreter or both, okay, and a debugger. It need not have a debugger because, but obviously all the basic IDEs today contains debugger, so a debugger, and also a terminal to run your output. So an IDE, basically you code in IDE. The IDE uses compiler and interpreter to compile or encapsulate or abstract your data, and the debugger, yeah, is used to remove the errors or mishappenings, which we call uh, exceptions. It handles those and the terminal gives you the output. Okay, so these are the three things you need to start code in Java. Okay, so Java is basically a very advanced programming language, and talking less, let's see how you code in Java. So first of all, you need to download these things I am listing below. You download JDK. It's from Oracle. First, before that, it had been written by Sun Microsystem, but it's now taken over by Oracle. So it's at Oracle. You need JDK, any version you can use for beginning, and you need BlueJ. That's the basic IDE I would suggest you to use, or you can go for some professional IDEs like NetBeans, etc. There are wide varieties you can use. NetBeans is there, Visual Studio is there. Okay, so there are many Java and C++ IDEs. So I told you that I would be talking about C++ also. So in this video I am talking first of all Java, and next video would be on C++, and this characteristic of OOP is same with Java and C++ both. Okay, so let's minimize this and take you to this IDE part. Okay, so here lies our JDK. The highlighted application is the Java Development Kit. It's Windows 64-bit, and the version is Java JDK 8. And here is the NetBeans, but I would be using BlueJ to demonstrate you the basic thing you need to do to start your coding. So this is BlueJ for Windows. Okay, so there are many more, like this is for Python, that's of different programming language, and this is Turbo C++, which I will be using to demonstrate C++. Okay, you can even use NetBeans or Visual Basic for C++. So let's launch BlueJ. So first of all, you need to install that JDK. After installing that JDK only, you install BlueJ, and here comes BlueJ. This is how BlueJ is there. So here starts BlueJ. Okay, so Here is BlueJ, and first of all I will be talking about this simple applications. How can simple programs, like how can you uh, create a hello world application. It's not hello world, it's hello world. Okay, so so first of all, this is the screen you get of BlueJ, and to start coding we need to first create a new project. Here is already a project created, but first of all you need to create a new project and name your project as you like, anything blah 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 blah, or you can create, okay, it will be created, but since I have created it, I'll create a new class over here. After creating a project you need to create a new class. Click on new class. Here you type your class name or whatever name you want to give to class. So I will be giving hello world. Okay, so you cannot use any special character in the name. You can only use underscore and dollar symbol and nothing else. Okay, okay, so this is the hello world class created over here, and you just need to double click this class to start editing this class. Just double click over here, and here comes the editor. So this is the editor I was talking about, and here's some pre-built application of the hello world. But we are not going to run this. We would be creating our own hello world application. Okay, so what is the basic structure of this program? So basically this structure would contain a class. Okay, it would contain a class, and this class would contain a function. This function will contain a data, and this data will be given as an output in the terminal. Okay, so it contains a class. Okay, let me show you. Okay, here is the class. This blue one is the class. It contains a function. The function contains a data, and this data is given out as an output on the screen. This is output, this is data, this is function, this is class. So when we run, we are invoking the class. This class will invoke this function. Okay, so this class will invoke this function will invoke this data, and this data will process everything, okay, and return to this function, and this function will return it to the terminal window, and here you get the output. Okay, so this is the basic structure of this program. So let's start coding over here. So first of all, we are going to declare the class. Okay, already the class is created, but still we need to declare the class. So I will be using class keyword. This class keyword is used to declare your class, and I would be writing the class name, which was hello world. Okay, so now we have declared the class, or you can say we have declared the car or the class as an object, as I told you in my example. So here our object is ready, and now let's give the objects. Okay, as I made the class, we are going to create methods, functions. Okay, so here our first function gonna come. It's public public static void main string args. Okay, so here I used a keyword public. What is public? Public is an access specifier. So what is access specifier? Access specifier is a keyword. Keyword are the small blocks or the preserved word which gives the compiler certain information to act upon. Okay, keywords are preserved words, and keywords cannot be used as variable name, okay, or identifiers we call them. So this is a keyword which tells the compiler up to where there the access this void this I mean this main function up to where it can be accessed. Public is the most open access specifier. It's public, it can be used in any other class of the same package, any other function of the same package, it can be used anywhere. Okay, basically default one is friendly. I have used public, you could have used private, etc, etc. They're protected, there are many more specifiers. Okay, and this function is static. Okay, and this is not gonna return any data type since it is the main function, so it's void. Void says this is the return type. Void means it is not going to return any data, and it is only going to print or process some data. It is not going to return any data. Okay, when there is no return from the function, we tell it void, and this is the name of the function, which is main, and this is the argument we passed over here, string args, or you can leave it blank. But if you leave it blank, you need to first create the object which will give it an argument, and then you can run the program. Okay, but I have given a default argument over here, so it would run directly. So here is the basic block we created. These are the curly braces which creates a block. The two gray points over there are a small block. You can create blocks anywhere. So what is basically a block? A block is the boundary line up to where a variable or function can work. Okay, up to where it is accessible. Okay, so this is basically a block. So if I declare an integer value, which is int, we call it, it's an integer symbol, integer keyword which contains only integer value. It can contain negative value, zeros, and long values. Okay, and not very long values. Okay, there's the limit. I would be not talking about the limits. I would not go so much theoretical, but I would give you some practical informations. So int contains integers. Okay, if I say int I, so what is I? I is the identifier by using which you identify this integer value. Okay, it's I. So I is declared under this block. This means that I is accessible only to this block. And what if we want to access I anywhere? Then we would not have declared it over here. We would declare it as an global variable. Global variable is actually a variable which can be accessed in any function in a class. Okay, for accessing a global variable, we need to give it an access specifier which will be given as public. Okay, int I. Okay, so here comes a global variable. We have declared a global variable here, and here what I created is a block for the class. It is a position up to where this class has access. Out of this block, this class doesn't have any access. So you can even give an access specifier to a class. You can write it public class. Okay, then now this class can be used in any other class of the same package. Okay, so here I have given it int, it's a global variable, and here it's a different integer value which stands with I. Okay, now there would be a doubt in your mind that both are identified as I and this is also as I. So if I use I over here, it would take both of them, or which one would it take, or it would not compile, will show you an error. So my dear, it's not like that. It's not gonna show error. It's gonna give priority to the local variable. This int I is a local variable, and it will be prior than the public int or the global variable. So if I call here I would be getting the value of this I and not that I. Okay, so this is priority system that works in. Okay, so I was telling So this is way I declare a block, we declare a block. So now let's remove, because we don't need any variable right now for this program. Okay, so we are learning how we print statements, or how we print the state, or how we show some message on the terminal window using Java. So we declare a class over here. This was a class that was declared. We created a block for the class, we created a function, we created block for the function, and now we are going to write the statement that would run it. Okay, before writing that, I would like to tell you that you can even add comments in your program. Comments are not displayed on the output screen, rather when you it gives some important messages, a message to the source in the source code, which the developer would want to give. If you want to refer to any part, like suppose this is a small program, so you need not refer anything. So what if you use big programs, like I have here a big program, you can see over here, it's a big program. So how would you refer to to a certain function or a method if you want to refer to it? So what are the hints you're gonna get, like where it is? So as you can see here, I have added some comments which would tell me, yes, this is the part which I want. This is the part where lifeline joker ends. Okay, this is the part where the lifeline ends, done. And here, which is the lifeline skip question starts. So this is the way we use this is the way we use different comments. So what is the way to write comment? If you want to write single line comment, double backslash any comment. And if you write a short note comment, so a black slash and an asterisk mark, and then you write whatever you want, and then an asterisk mark, again a backslash. Okay, so you can write multiple statements over here, like as you see, another star mark, write whatever you want, and then another star mark, you just close this part. Okay, so this is how you write comments in your program. So here I would be writing a comment. So let's write printing. Okay, and now let's start. So what is the print statement you gonna use in Java? What code we gonna give it to print a message? So the code is capital, and remember Java is case sensitive, so you need to see which case are you writing, is capital letter, small letter, it matters. So capital SYSTEM, system dot out dot print. You can end here, or you can write another word, that is ln. So what difference will these two letters make? System.out.print will print the message in the same line, while ln represents line next. It will print the next message in the next line and will not continue from the same part. Okay, so there comes the difference, system.out.print ln. Okay, or you can write print, because the single line statement it is not going to make any difference. And what we are going to print is a string value, and every string value is written under double quotes, just like when you speak. Okay, and this is the argument we're gonna give to the print output. So arguments are always given under brackets. Okay, so bracket open, double quotes open. Since it's a string value means like anything, any letter, and not alphabet, letter. Okay, or any statement, okay, or sentence. So it's hello world. Okay, hello world, and we're gonna close it, and we're gonna turn green, showing that this is a message or a string value. And we're gonna close the argument. And every line in Java compiler, how will it know that you have ended that line? Java is not smart enough to understand what you want, or it can read your mind. So what you need to write here, that Java knows that the line has been ended. You put here a semicolon. Semicolon indicates or you can say colon is a full stop in the language of Java. So here we put a full stop or the semicolon. Okay, and here is our program ready of hello world. So now we here click the compile button, and here you see our program gets compiled without any syntax error. Now we close this editor, and here is hello world. We right click over here, we use the main method void main string args. We click that, here is the default argument, and we click OK. So here comes a terminal window, and here is the output hello world. Okay, so let's add some more lines over here, like system dot out dot println java is very easy. Okay, and this time we are not going to put this ln over here. Okay, we are not going to print in line next, we are going to continue over there. So for this we need to write another line, system dot out dot print what, it's nice. Okay, any message. Okay, and a space would work great. Okay, so now let's compile without any syntax error. Right click main argument, okay, and here we go. Hello world, that was from the previous one, you need not see that. So see what I am highlighting now. This is our output of the present part, it's hello world. Okay, that's right, as I said it would come in line next because ln was there, so it came in line next line. This was from the first one, and from the next line it started. And java is very easy was also from the was not from the line next. I mean it was not from line next, so it came over here. And a minute please. So okay, sorry, yep. So because we used line next in hello world, so after printing the hello world, the cursor or the printing head came over down over here. So in this part in java is very easy, we hadn't used any line next, so the cursor printed over here. Okay, printed over here and stayed here, and the third line it printed it's nice, and since it's nice is also without line next, so the cursor is still here. Okay, so this is a way we print statements in java. So this was my small introduction and a small example how to code simple, a very basic application of printing a statement in java, and a brief knowledge about object oriented programming language. So guys, I would be bringing more videos on java and c++, and not only basics, I would be telling you about different types of programs, function overloading, making packages, making library packages, creating data structure arrays, and different graphical GUI operating system. So even I would be talking about how can you create your own artificial intelligence using java. So this was all the thing that I like to share in this video. So I'll be continuing about c++ in my next video, and also about some fragments of java in my next video. So till then, take care, and please do like and subscribe if you found this video to be useful, and please do share with your friends. Thank you.